Hello, my amazing algebra half students. This is Mrs. A, and I love math. And today we're doing lesson 29, and it's all about multiplying fractions and whole numbers. So we're going to learn a lot today about what this means and what this means. So here we go. When we are multiplying fractions, remember fractions have numerators and denominators. And the numerator of the fraction tells you how many pieces of the fraction you have. And the denominator tells you how many pieces that are equal in size would be in a whole. So let's just look at 3/5, for example. If we were trying to see what 3/5 really meant, we would divide, pretend that that is equal fifths, okay? We would divide the pie into 5 equal parts, and then we would be talking about 3 of those 5 equal parts, and that would be 3/5. If I wanted to know what 1/5 was, I would be talking about only one of those 5 equal parts, okay? Now what we're talking about in this lesson is what it means to multiply them together. Okay, well, let's think about something that we can actually visualize, okay? So let's talk about something like 12 balls, okay? And if I wanted to take 1/2 of 12, 1/2 of 12, that's the same thing as 1/2 times 12. So let's take our 1/2 times, I'll make our 12 a little bit bigger. And whenever we're talking about 12, we can divide it by 1 because 12 divided by 1 is still 12. And that makes it clear to us what is the numerator and what is the denominator of the fraction. And when I multiply straight across, I get 12 divided by 2, which is 6. And we know that 6 is 1/2 of 12. Okay, so when I am taking 1/2, I'm dividing into 2 equal parts, and when I do that, each part has 6. Okay, so what if I wanted 1/4 of 12? Well, when I multiply across the top, I get 12, and when I multiply across the bottom, the denominator, I get 4, and we know that 12 divided by 4 is 3. Okay, so 1/4 of 12 is 3, and we know that 1/4 of 12 means that I'm taking the 12 items and dividing into 4 equal groups, and I'm choosing one of those groups. So 3, 1, 2, 3 is 1/4 of 12. Okay, well then if I wanted to talk about 2/4, 2/4 would be 2 of these little circles here, these little groupings, and 2/4 would be 6. And 2/4 is the same thing as 1/2 of 6 was. Okay, so we're doing a lot of fraction work here, and I want you to try to understand what's going on. So let's go back to this problem right here, and we'll erase some of this off the board. So when we're multiplying fractions, we multiply across the numerator. 1 times 3 is 3. We multiply across the denominator. 5 times 5 is 25. And I cannot do anything to simplify that answer. Okay, 1/5 times 3/5 is 3/25. Okay, what about this one right here? 2/9 times 4. That can be a little bit confusing because we want our fractions to have a numerator and a denominator. But that's no biggie because we can just divide by 1 and 4 divided by 1 is 4. And then we multiply across the top and get 8, and across the bottom and we get 9, and 8/9 is the answer. Okay, so now I have some more boards here. Let's look at this one. Okay, when we're dealing with the fraction here, there is, your book is saying there's a top to a fraction and a bottom to the fraction, but there's no middle. And very often you'll see a 4, a whole number, sitting kind of in the middle. Well, just change that 4 to a 4 over 1, and then you will not be confused about where to multiply it. Okay, so 4 times 3 is 12, and 1 times 5 is 5. Now, this one is an improper fraction, isn't it? So 12 over 5 is the answer, but we would want to put it into a mixed number. Do you remember how to do that? We say, well, 12 divided by 5 goes 2 whole times, and 2 times 5 is 10, and 10 from 12 is 2 left over. And remember how to go from a mixed number back to an improper fraction? 2 times 5 is 10, plus 2 is 12, 12/5. All right, we did that in a lesson, I think the last lesson we were doing that, weren't we? Okay, so we're just practicing it a little bit. 12/5 is the same as 2 and 2/5. So we want to remember that fractions have numerators and denominators, and to save confusion, we will take the 4 and write it as 4 divided by 1, and then we can keep straight our numerators and our denominators, multiply straight across and straight across. Okay, now the next one, we're going to do a little bit of reasoning here. Now, I could just multiply across and say, well, we're going to make this a 15 over 1, and 1 times 15 is 15, and 5 times 1 is 5, and 15 divided by 5 is 3. And that is true. Okay, so the answer is 3. But let's visualize it a little better, okay? Because sometimes we're going to get some pretty big numbers, and sometimes we're going to find out that it's much more efficient to think, instead of multiplying all the time, think, hey, is there a way that I can divide first to make it a little bit faster and quicker? Keep my numbers a little bit smaller, okay? Now, if I'm talking about 1/5 of 15, I'm really thinking, okay, how can I divide 15 into 5 equal parts? Well, 15 divided by 5 is 3, isn't it? So we have 3, 3, 3, 3. 3 times 5 is 15. So 1/5 of 15 is a 3, isn't it? So if I'm doing, once I've divided 15 into 5 equal parts, then 1/5 would be one of those parts. So 1/5 of 15 is 3. Okay, well, look at this one. Here we have 2/5 of 15. Now, we already decided that dividing 15 into 5 equal parts was 3 plus 3 plus 3 plus 3 plus 3 plus, so 5 times 3. And so 2/5 of 15 would be 2 of the parts. So 2/5 of 15 is going to be 6. Okay, if 1/5 is 3, then 2/5 has to be 6. Okay, so we can still get 6 if we did it the long way. All right, we would put a 1 down here, and we would multiply. 2 times 15 is 30. And 5 times 1 is 5, and 30 divided by 5 is 6, right? Or we could have done what we call canceling. We could have said, you know what, I'm going to end up, because this times this is going to be 2 times 15. And then over here, I got 5 times 1, and it's all one big happy number. Could I make it a lot simpler mathematically to just divide the bottom and the top by 15 at the beginning. And then 2 times 3 is 6. And I stay away from big numbers. Okay? So that's what makes fractions a lot of fun, is there's several different ways that we can do them and still get the right answer, because we are applying the principles that God put into the universe. And one of those principles was, you know what? It's okay to divide or multiply the top and the bottom of a fraction by the same non-zero number. Okay? So here, instead of multiplying 2 times 15 and getting a bigger number and then dividing, I went ahead and divided the 5 into the 15 first, just like I did here, and got 3. And then I said, oh, I'm just talking about 2 groups of 3. And 2 groups of 3 is 6. Okay, so here we already decided that we had a 3 and a 3 and a 3 and a 3 and a 3, because 1/5 of 15 is 3. And now we're talking about 4 of those 5 parts. So 3 plus 3 plus 3 plus 3 is 12. Okay. Also, we know that 15 is 15 over 1. And we know that of, in mathematics, means times. So now we could multiply 4 times 15 is 60. Big number. And 60 divided by 5 is 12, because 12 times 5 is 60. Okay, if we know our multiplication facts, we know that 12 times 5 is 60. Okay, but an even easier way to do it is to do what? Is to say, you know what? When I multiply these two together, they're all going to be in one big fraction. Why don't I just go ahead and divide the bottom by 5 and then get 1, and divide the top by 5 and then get 3. Okay, so then I get 4 times 3 is 12. 1 times 1 is 1. And 12 over 1 is 12. Isn't that simple? Okay, so that's what we call canceling. So now, let's look at this one. And we're going to think about it several different ways. But look at that number. Look what a big number 42 times 3 is going to become if we just do this with multiplication. But if we think back to the problem of 15, we divided the 15 into 5 equal parts because we were trying to take fifths. Well, now 42 into 7 equal parts, each part would be 6, wouldn't it? So 6, 6, 6, 6, 6, 6, 6. 1, 2, 3, 4, 5, 6, 7 sixes. 7 times 6 is 42. So now that we've divided the 42 into sevenths and found that each seventh is a 6, then 3 groups would be 6, 6, 6, or 18. Isn't that easy to visualize it this way? Okay, so let's work the same problem, but we're going to do it with multiplication and then with canceling. And then you get to decide which one you like better. Okay, so on the top we're going to multiply. And we're going to put 42 over 1 so we don't get confused. And then we're going to say 3 times 42. Well, 3 times 42. 3 times 2 is 6 with nothing to carry. 3 times 4 is 12, so I get 126. 7 times 1 is 7. Now I've got to divide. So I'm going to have to do long division and say 126 divided by 7. 7 goes into 12 one time with a 7 and a 56. And 7 into 56 is 8. So my answer is 18. Wow, that was a lot of work. So my answer was 18. Okay, so we're just going to put it there and circle it, and I'm going to erase this because I need room for this problem, which is the same problem. But now I'm going to do this one with canceling. I'm going to say, well, you know what? These two fractions are going to wind up being one big fraction. And the top of the fraction is going to be 3 times 42. And the bottom of the fraction is going to be 7 times 1, which is just 7. So to save myself a little bit of time and not have to multiply into these big, big numbers, I'm going to say, well, let's take a shortcut. Let's take 42 and 7 and divide them both by 7. As long as I do the same thing to the top of the fraction as I do to the bottom of the fraction, I will always come out with the same answer. So 7 divided by 7 is 1. And 42 divided by 7 is 6. So now I don't even have to mess with the 42 anymore. And then 3 times 6 is 18. And the bottom is 1 times 1, which is 1. And since it's just a 1, we don't need to do anything with it. Okay? So now, remember what we started with? We started with this picture. Okay, where we divided the 42 up into 7 equal parts. And we found out that each part was a 6. Okay, then we chose 3 of those parts and we got our answer. Isn't that just what you're doing on the bottom down here? You're taking the 42 and you're dividing it into 7 equal parts. And each part is a 6. And then you took 3 of the 6s and you got 18. And that is cool. Okay, so this is our last example, and then we start our practices down here. So we have 5/7 of 12. Now, this one, I have less flexibility because I can't cancel anything. 7 cannot cancel with 5. 7 cannot cancel with 12. So I'm pretty much stuck just multiplying it straight across. But I'm going to remember that my of means the same thing as times. And I'm going to make it easier for myself just by putting a 1 underneath the 12. So this time, 5 times 12 is 60. And 7 times 1 is 7. And I have an improper fraction. So I'm going to have to do long division. So 60 divided by 7 is going to go in 7 times 8 is 56. So we'll put an 8 here. 8 times 7 is 56. I subtract and get a 4. And there's nothing else to bring down, so it's going to be 8 4/7. So my answer is 8 4/7. That's the mixed number. That is the same as this improper fraction. Okay, so remember, going back to the improper, 8 times 7 is 56, plus 4 is 60, divided by 7. All right, so now let's look at this one. This one, we are going to be able to use the shortcut of cancellation. So we're going to change the of to times. We're going to put the 1 down here. Now, I could just multiply and get 4 times 30 is 120, and then 120 divided by 3 is 40. I could do that. Or I could take the shortcut and I could say, well, 30 has a 3 in it and 3 has a 3 in it, and they're going to all be one big fraction anyway. So why don't I divide that by 3 and get 10, that by 3 and get 1. 4 times 10 is 40. 1 times 1 is 1. 40 over 1 is 40. And that is not a fraction, is it? It's a whole number answer there. Okay, notice that 4/3, we started with 4/3, it was greater than 1. It was an improper fraction. The 4 is bigger than the 3. So the answer should be greater than 30, and it's 40. Okay, so here is our next practice. Oh, that was a practice problem, and I forgot to tell you to pause your video. So here is another practice problem. Pause your video. Okay, so we're going to take the of and turn it into a times sign. we're going to take our 15 and put it over 1. This one does not have any cancellation that's going to help us out because 4 does not go into 15 and 4 does not go into 3 evenly. So we're just going to multiply across the numerator. 3 times 15 is 45, and 4 times 1 is 4, and then I have to find the mixed number that is equivalent. So 45 divided by 4 goes 11 times. Because 11 times 4 is 44, we have 1 left over, so it will be 11 and 1/4. And that's the answer to that one. And here we come with your very last practice problem for this lesson 29, and pause your video. Okay, again, can we cancel it all? 5 and 7 have no factors in common. 3 and 7 have no factors in common. So we're just going to have to multiply. So we're going to say times and put it over 1. 5 times 3 is 15. 7 times 1 is 7. 15 divided by 7 is 2 whole times. Because 2 times 7 is 14, we have 1 left over. 2 and 1/7 is the same as 15/7. 2 times 7 is 14 plus 1 is 15 over 7. And that is the end of our lesson 29. And this is Mrs. A. And may God bless your day.